Sweat chloride estimation is required for making a diagnosis of cystic fibrosis. The commercially available equipment is expensive, not easily available, and per test cost is high. We developed a indigenous method for estimation of sweat chloride in our patients for cystic fibrosis, and the cost of equipment is around 1000 rupees, which is much lesser than the 4 lakh rupees of commercial equipment, and the per test cost is around 25 rupees as compared to rupees 1500 per test by commercial equipment. The test is divided in two parts. Part 1 include collection of sweat by pilocarpine iontophoresis, and part 2 includes estimation of chloride by titration.
For collection of sweat, the materials required are methyl alcohol, MilliQ water, 1% pilocarpine, cling film, forceps, filter papers, and the instrument. The instrument consists of an ammeter and the electrodes. First, clean the flexor aspect of the forearm properly, first with methyl alcohol and then with distilled water, also drying it after that. Then soak 2 layers of filter paper thoroughly in 1% pilocarpine. Place it under the positive electrode and secure it on the distal aspect of the forearm using bandage. Next, soak 3 to 4 layers of filter paper thoroughly in distilled water, place them under the negative electrode and secure them on the proximal part of the forearm using bandage. Care should be taken so that the electrodes are not too close to each other. Start the connection. Once the voltage goes beyond 1.5 milliampere, start counting. If the current goes beyond 4 milliampere, decrease the voltage. At the end of 5 minutes, switch off the mains, remove the electrodes, clean the area properly, dry it, and then place a filter paper from a pre-weighed bottle using a forceps over the area which was under the positive electrode. Secure it with a cling film. Ask the child to wait for 30 minutes, preferably in a warm place. After 30 minutes, switch off the fan. Then remove the cling film carefully and remove the filter paper using a forceps. Put it back into the pre-weighed bottle immediately so that there is no loss of sweat. Weigh the bottle and record this weight. Then add 8 ml of distilled water to the bottle. Keep it at room temperature for overnight. The second part includes the estimation of sweat chloride. This requires nitric acid, mercuric nitrate, standard saline of known strength, a solution of diphenyl carbazone, tuberculin syringes, droppers, and clean test tubes. First, take a clean test tube, add 0.5 ml of the standard saline to it using a tuberculin syringe. Add 1 drop of nitric acid to it. Add 2-3 drops of the indicator, diphenyl carbazone. Then titrate by adding mercuric nitrate 0.002 N drop by drop along with shaking of the tube. Observe for the change in color. As soon as the color changes to pink, this is the end of titration, and note this volume of mercuric nitrate as the standard volume. Next, take another clean test tube, add 2 ml of the eluted sweat solution using a tuberculin syringe, and follow the previous steps again. Add 1 drop of nitric acid, then add 2-3 drops of the indicator diphenyl carbazone. Then titrate by adding mercuric nitrate drop by drop and shaking the test tube. As soon as the color changes to pink, this is the end of titration. Note down the volume as the test volume. Calculate the sweat chloride using this formula. Chloride in milliequivalent per liter is equal to 8 plus sweat weight divided by sweat weight into 2 multiplied by 5 multiplied by test volume by standard volume.